Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We from Group 8 consists of 4 members, leads by Muhammad Nakiuddin Wa'i bin Abdul Malik, and 3 other members are Muhammad Wajidi bin Muhammad Iman, myself, Nur Afrina Batrisha, and also Nurdini Farzana. So we're gonna explain about ground beams and floor beams. Alright, so for introduction, drawing used for these assignments are from class exercise drawings, AQS to 2100 ground beam slab column roof, 1 to 3. It is a 3-story bungalow house. The explanation of this discussion is based on Malaysian Standard Method of Measurement of Building Works, second edition, SMM2. Section involve section D for excavation and earthwork, and section F for concrete works. Alright, so there are 3 things that will be discussed, which is the principle of measurement, costing, and then construction technology. Next. Alright, so for the principle of measurement, first we're going to explain 5 that will be emphasized on the clause, which are on the clauses and description, unit of measurement, example of description, principle of measurement and calculation, and also we include example of slip sort. Next. Right, so we start with ground beam. Next. Right, so the work element of ground beam is work below lowest floor finish, WBLFF. Right, assumption made for this discussion for ground beam, which topsoil excavation and excavation to reduce level have been completed. Only excavation trench for ground beam need to be measured. Right, so the general items that need to be measured for ground beam are listed in the table below, which is the first one, excavated trenches for ground beam, followed by removal of excavated material, disposal of surface water, lean concrete for ground beam, concrete in ground beam, formwork to side of ground beam, reinforcement bar in ground beam, and lastly the stirrups in ground beam. Right. Next. Right, so this is the slip sort form. For better understanding, the items that need to be measured based on the drawings we listed in this slip sort form. Right, so that, as you can see, 1 to 5 is the same, but there's slight difference at the 6 to 8 items, which is there is classification for the item. This will be explained later. Alright, so in practice, these items will be listed on the first page of the measurement as the taking off list, in order to prevent the calculation of the item to be omitted. This practice also allows the surveyors to recognize the status of the items by crossing the items that have been measured. Alright, next. Alright, so for the first one is excavate trenches for ground beam. Clause and description, which is the general one, is D10 and D11. Depth excavation and stating the level of the excavation start, and then D.12.7, the excavation for ground beam. Right. So the unit of measurement shall be given in meter cube. Example of description: excavate trenches to receive ground beam starting from reduced level, maximum depth not exceeding 1 meter. Alright, so the principle of measurement and calculation, firstly we need to calculate the volume of trench excavation. So the length and the width of excavation is same as the size of the ground beam. But then for the depth of excavation, ground beam need to be added with lean concrete thickness. Alright, next. Alright, so for the drawing, we use ground floor 1 for example on this presentation. So as you can see, the length is 6241, and then the depth is 300 and the width is 150. So on the right side, you can see the which is the depth that we need to calculate. All right, next. So here the example of calculation: length, multiple width, thickness, and then we can get the answer. Next. So here is the example on slip sort. Mention at the side cast, and then multiple at the multiple section. Next. So the first second item, which is the remove excavated material. So the clause and description is D.18 and D.19. Alright, so the unit of measurement shall be given in meter cube. Alright, so the example of description: remove excavated material from the site, location at contractor discretion, including provision of chute, dump, payment for royalties, and other changes as per the approval of SO. Right, so what we need to know that the volume for disposal excavated material is equal to the volume of excavated trench for ground beam. Right, so next. This is some example of overview of disposal of excavated material. Next. This is so as the calculation is same, so we just provide the example on slip sort, which is the calculation is same, but the heading and the description is quite different. It's different, sorry. Next. So the next one is disposal of surface water. If there is excavation, then this item will is compulsory. So the disposal of surface water, the clause is D.14, which is that need to emphasize is free of surface water. Unit of measurement shall be given in item. Example of description: allow for keeping the surfaces of the site and excavation free of surface water. Principle of measurement: an item is taken to allow the opportunity of removing rainwater on site and in the excavation. Next. There are two types of disposal surface water, which is the pump system and the manual label. Next. Alright, so this is the example on slip sites.
Okay, so next I will explain to you about the item which is link concrete. The clause for the link concrete is F.3.1, which is the measurement, the unit of measurement is in meter cube. So for the example of description, plain in situ link concrete grade 10, blinding screeded not exceeding 100 mm thick, laid on under the ground beam. So the principle of measurement on calculation is to calculate the volume of the link concrete, which is length of the beam, width of the beam, and the thickness of the link concrete. We multiply all of that. So this is some example and illustration where and how that link concrete being used under the ground beam. So for the principle of measurement, you can see that we need to know the size of the ground beam and the thickness of the link concrete. So after that, we also need to know the number of the beam and multiply all that. This is some example of the link concrete on the slip sort, which is we have the heading, description, and at the side cast we have all the size that we need to use for measure the link concrete. So next is reinforcement concrete in ground beam, which is the assignment clause that used for this item is F.1.1, F.3.1, and F.3.5, which is need to state the kind and quality and be measured in meter cube, and it is for ground beam, which is the example of the description is reinforcement in situ concrete grade 25 in ground beam. The principle of measurement and its calculation is to multiply all the length, width, and the thickness of the ground beam. This the same picture or the same drawing of the ground beam, which is we use GFL1. So the principle of measurement, like before, we need to know the length, the width, and the thickness of the ground beam, and we multiply all that and multiply again with the number of the beam, and we get the measurement. So this is some example of on the slip sort that we use to measure the reinforcement concrete in ground beam. So for the formwork, the SM clause is F.11.1, which is need to be categorized by its category, which is 250 mm high, 252 mm 500 mm high, 500 to 1 meter high. So the example of it it need to be measured in meter square or meter. So for the example of discretion, class F1 formwork to face and edges of foundation to retrieve to the both side of the ground beam exceeding 500 mm but not exceeding 1 meter high. So the principle of measurement and its calculation is to calculate area of the formwork. Area of the formwork is the length of the formwork, which is the length of the wing, times by height of the formwork, which is thickness of the wing, and times number of the formwork, which is for ground beam we need to have the both side, which is at the right and at the left. So this some illustration or sketch that we can see that they have two formwork, which is at the right and at the left. So the principle of measurement, like I have said before, we need to know the size of the ground beam and number of beam that, and differentiate is that we have two number of formwork at the right and the left. So after we multiply all that, we will get the measurement of the formwork. So this is some example on the seesaw. Next, I pass to Wajidi.
Alright, so for the next one is the item is a high tensile reinforcement bar in ground beam. Right, so the clause and description is F.8.1, which is kind and quality. F.8.2, the what should be given kilograms or tons, and also the stating the diameters. Each diameter shall be given separately, either 10 mm, 12 mm, 16 mm. Then we need to give it separately. Right, so that's why the classification at the taking off list is different. All right, so F.8.4.A is for the ground beam. All right, so the unit of measurement is kilogram or tons. An example of description is 12 mm diameter high tensile steel reinforcement in straight and bend bars in ground beam. All right. So for the principle of measurement, firstly we need to measure the length of the longitude bar. So the length of the longitude bar, firstly we need to take the length of the beam, and then we deduct the length of the concrete cover, which is the gap between the reinforcement and the concrete. Right. So the next one is we need to add the length of the band, which is we need to add the length of the band. But if the length does not provided in the drawing, band formula can be used, which is 16 multiple with the diameter of the rebar. So in this case, 16 multiple with 12. Right. So next we deduct the length of the concrete cover of the band. Right. So if the calculation of band length use formula, then there is no need for deduction. Right. So last step is we need to convert the length to kilograms or tons. Right, next. Right, so as you can see at the right side, there is the concrete cover, which is the gap between the reinforcement and the concrete. So the bottom picture is we can see the yellow one is the reinforcement bar, and the one that going up and going down, that is the band. All right, next. Right, so here is the calculation as stated before, the length, and then we deduct with concrete cover, add band. So in this case, we use formula, so there is no need for deduction of the concrete cover, concrete cover band. All right. So we convert it, and then we can get the answer. All right. So here is an example on slip sides. As the side cast, we need to mention all the calculations, and then at the multiple section, we put the length, and then we convert after we get the length, the total length. All right. Next, we
pass to next is link stirrup in ground beam. Usually the clause is F.8.4.A. So for the unit measurement for the link or stirrup shall be given in kilogram per meter. So for the example of the description is my steel bar reinforcement to BS 4449 in ground beam, 10 mm diameter link, ring and binder and the like. It same goes to the reinforcement bar. It needs to classify with each their own diameter, which is we have 10, 12, 16 and others. So the principle of measurement and calculation is we need to measure the length of the stirrup, which is we take the width and the thickness of the beam and upper and bottom, left and the right, and deduct the length with the concrete cover. After that, we add the length of the hook, which is we use the formula. For the one hook, we need to use 9D. So for the one link of stirrup, we will have two number of hooks, so it will be 18D. So after that, we convert. After we get the meter, we convert it to the kilogram or ton. So these are some illustration and drawing that how that and where the stirrup have in the ground beam. Next is this is the principal measurement and its calculation. Like I said before, we need to know all the size of the ground beam. Then we find the length of the stirrup. The difference is that we need to know the number of the stirrup, which is we find the length of the beam and we divide by the gap of the stirrup, which is 250 mm. Then plus by 1. Then we get all the number of the stirrup, which is 25. After that, we times the number of the stirrup with the length, and we get the total length and convert it to the kilogram, which is 20.98. So this is some example of the stirrup that we use in SISOP. So next, we will be explain about the floor beam. So the work element for the floor beam is frame, which is the general item is concrete in attached beam, formwork to side and soffit of attached beam, reinforcement bar in attached beam, and also the stirrup in attached beam. So this the example in Taki of list that like what GD has said before, we need make sure that all items be calculated to get the accurate of the measurement of the item. So this for item just quite same the ground beam. So the first item is concrete in ground beam, which is the clause is F.1.1 for the kind and its quality, F.3.1 for the unit of measurement, and F.3 and 14 for the beams. It should be measured in cubic meter, which is the example of the description is reinforcement in situ concrete grade 25 in beam. So for the principle of measurement is like same as before, we need to times the length, the width, and the thickness of the beam. So this is the drawing and example of the floor beam. So the calculation, we need to know the size of attached beam with length, width, and thickness. We multiply all it and we multiply again with the number of beam which is we only have one here. So we get the measurement. So, this is some example on the seesaw. So next is the formwork to the side and soffit of beam. The differentiate is that at the floor beam we have the soffit, which is the class is F14.1. So the measurement of the formwork is M2, which is meter square. The example of description is class F1 formwork to face and edges of the structure to retrieve to the both side, and also soffit of the floor beam not exceeding 1 meter high. So the principle of measurement, that is we need to calculate the area of the side of formwork, which is the length formwork, height of times height of formwork, and times number of formwork, which is the both side, left and the right, and then add the area of the soffit. Soffit is the length of formwork, which is length of the beam, times width of the formwork, which is width of the beam. So this example of formwork that been used in to make the floor beam. So for the floor beam, we have the length, width, and thickness. So we have we find the number of formwork, which is 2 at the both side and 1 on the soffit. So the how we measure it, we measured first of the side of the beam and then soffit at the beam, and we add both of them. So this is some example. We can see that the different we have we measure the side first and the soffit, the seesaw. So next.
Next one, I'm going to explain about the high tensile reinforcement bar in beam. So is The calculation is same. Alright, so, I will explain about the clause first. Alright, so the clause is F.8.1 for the kind and quality. F.8.2, we need to calculate in kilogram or tons and also stating the diameters. Each diameter shall be given separately. F.8.4.7 is for the beams. Alright, so the unit of measurement, kilogram or tons. Example of description, I use a 12 mm diameter, which is a 12 mm diameter high tensile steel reinforcement in straight and bend bars in beam. Right. So the principle of measurement and calculation is same as I've stated in the ground beam. Right. Next. Alright, so here I want to show you that the concrete cover here, and also there is the yellow one is the reinforcement bar. Alright, next. Right, so for the calculation, it's the same. We take the length and then we deduct the cover, and then we add band as we use formula, so there is no need for deduction of the concrete cover for the band. And also we need to multiply with the number of the reinforcement in the beam, right? So it's same as the ground beam just now. And then after we get the total length, so we convert it, and then we can get the kilograms. Next. So here is an example on slip sort. Same as the calculation just now. Just need to mention at the side cast. Next.
Okay, so the last item for the principle of the measurement for the floor beam is link and the stirrup of the floor beam, which is we referring to the SMM. The clause is F.8.5, which is the measurement is also like before kilogram. So it's quite same to the ground beam. The example of this description is mass T-bar reinforcement to BS 4449 in floor beam at 6 mm diameter link, a ring, and also binder and the like. So for the principal measurement and calculation is same in the ground beam. We need to measure the length of the stirrup, then deduct by the length of the concrete cover. After that, we need to add the length of the hook. Then we convert it from meter to the kilogram. So same. This is some example how and where the link in or stirrup in the floor beam. So it quite same a floor beam. Just from here we can see that difference is that we use RC stirrup in this floor beam. It more smaller than in ground beam. So the principle of the measurement is same. We need to find the length of the stirrup and number of stirrup and convert it after multiply both of them. So this is example of the on the side sort. We can see the calculation need to be shown in the side cast. So I think that's all for principle of measurement. So on the next presentation, costing. So let's.
Okay, so for the price of labor, we have identified 4 of it which is involved in the construction of beam. Firstly is general labor, which is RM85 per day. Concreter, which is RM94.50 per day, and the carpenter for the formwork 250 per day, and also excavator operator for the excavation for trench, which is RM150 per day. Okay, so now for the first item, which is excavation for trench, the rate is RM80.20 per meter cube, and this is the example of BQ. Let's say the quantity from the principles of measurement is 1. So the total costing for excavation for trench is RM80.20. Okay, for the second item, which is removal excavated material, the rate for this item is RM34.50 per meter cube. And for the example of piece of quantity, let's say the quantity same as the excavation of 4 trench, so the total cost will be RM34.50. Okay, so move on to the next item, which is link concrete. So this is the costing for link concrete. The rate for link concrete per meter cube is RM15.70. And for the BQ, this is the example of BQ, and the quantity from the measurement is 1, so the total cost for link concrete is RM50.70.
Next, we'll proceed with the next item, which is build up the rate for reinforced concrete. So to build up the reinforced concrete is a little bit tricky and long because it has material costs, mixing costs, and operation costs, and labor costs. On the slide, it has explained how to build up the rates for material costs. The cost of material need to be calculated in meter cube. If the construction use a mixer to mix the concrete, so the mixing cost and operation cost is needed. So for the mixing cost, the mixer used per meter hour is being calculated, and for the operation cost, the concrete per meter cube, the cost concrete per meter cube is calculated. Okay, the last one for the concrete is labor cost. The first one is need to be find the cost per hour for the general labor and the skill labor, and also for the prepare and fixing, the output of the labor, and the last one add on the wastage profit and also overhead. Next is formwork. The first one need to be calculated is the all-in rate per meter square for formwork. Then, like always, add on the wastages and overhead and profits. The example of the all-in rate in the slide is taken from a BQ. To build up rate for the reinforcement for ground beam, the first one need to be calculated the material cost. So the price of the 1 kg diameter of reinforcement need to be determined first, then allow for spacer and wastages must be included at the end of the material cost. Next, for labor cost, only general labor is used. As always, add on the overhead and profits. So, for the floor beam, the reinforcement for floor beam is similar as the build-up rate for the reinforcement for ground beam. So here the different because the rate is taken from the rates from the JKR. So in the JKR there are differentiate between the floor and ground beam, the reinforcement for floor and ground beam.
Okay, for the last item, which is stirrup or links, this is the costing for stirrup or links. The price for the reinforcement stirrup we get from the JKR rates online, and the price for 10 mm diameter bar is RM3.48, and the rate per kg for stirrup is RM6.85. For the BQ, so this is the example of BQ, which is the quantity we get from the measurement is 21. So times with the rate RM6.85 equal to RM143.85 for stirrup costing. Okay, for the stirrup in the floor beam, the costing is the BR rate is basically the same as the ground beam, but the difference is the price of the reinforcement stirrup, which is for floor beam the the price that we get from the rate ZKR rates online is RM3.53. So the total rate per kg for stirrup in floor beam is RM6.91. And for the BQ, this is the example of BQ, and the quantity we get from the measurement is 3. Let's say it's 3, and the total cost for stirrup is equal to RM20.73 for stirrup in floor beam. Okay, so now we go to the construction technology.